DJ Khaled.
I got them keys. I got them keys. I got them keys. I got them keys. We go to go, we gon' bleed the film. I know the judge, I'ma shoot him some chips. I got them keys. I got them keys.
When deciding upon our final project for our ES50 class, we wanted to create something that would actually solve a problem that Harvard students face every day. In general, Harvard students are constantly being locked out of their rooms or losing their keys. Therefore, we decided to design an unobtrusive door opening system that would work via RFID chip in a server system. This would allow easier access to the room via replaceable RFID tags or even the option of sending a text to open the door. The possibilities are endless.
As far as the hardware components of the project, we used two Arduino boards connected together using I2C master-slave protocol. This is the master Arduino, and it's connected to a 13.56 Hertz RFID shield as well as an RFID module. To pass data from this Arduino to the slave, we used these wires, which we soldered to header pins in order to make them easily disconnectable. This Arduino also is connected to a speaker which makes a beep noise when an RFID is found. When data is received by the slave, it is interpreted by this Arduino, which is connected to a Wi-Fi shield and a servo motor that turns upon the successful recognition of an RFID or a successful text confirmation. This Arduino is also connected to a resistor and a button that allows us to manually add individual RFIDs to our server. And this Arduino also is connected to a battery pack, which provides power for both the slave and the master.
Initially, we were deciding between using a servo motor or a linear actuator in order to push down the door handle. The advantage of the servo motor would be a lower profile and easier implementation. However, we were not sure that the torque provided by the servo motor would be enough to actually push down the handle. After torque calculations, we decided upon a servo system with a fishnet wire attached to the servo and the door handle. The rest of the mounts were laser cut, thus creating a relatively small and stunning system that through a variety of trigger systems such as text or RFID would start the servo motor, pushing the door handle down. In conclusion, we were able to create a sleek and functional system to open a dorm room door, but also allow for the door to be used in a normal fashion.
When the outer Arduino detects an ID, it sends that data to the inner Arduino. That then makes an HTTP request to the web server, which we wrote in Node.js, which looks for the ID in the database of approved IDs. IDs can be configured to require confirmation via text message, in which case the server sends a text via Twilio to the owner of the lock and waits for a reply before allowing access to the Arduino. All of this mutable state is managed by a finite state machine implementation on the inner Arduino. Good.
So our project works as we wanted it to, but there are a couple issues that we still need to work out. The first is that our battery only lasts for around 10 hours, which would be inconvenient in practical use if you were going to be gone all day. And as a solution, we would eventually like to power our system using a solar panel rather than a battery pack. Additionally, we're unable to put our system on Harvard's Wi-Fi because we couldn't install the profile necessary to do so. And to fix this, we could either research and find if there are Arduino drivers for doing this sort of thing, or connect a SIM card to Arduino and switch to just a text-only interface. We'd also like to extend our project to other different triggers for opening the door, such as potentially Apple Pay Cash or Venmo.
DJ Khaled.
I got them keys.